we are moving on to CO49, where we get a little bit of graphing. Okay, we've talked about functions and relations and domain and range and everything like that. But now we're going to start to apply these function tables and these functions to coordinate planes. And there's basically kind of four things that we're covering here. Okay, in today's lesson, you're going to write each ordered pair contained in the table. Just kind of practice that going from the table to the ordered pair. Write a rule for the table, which we'll talk about what that rule is if you don't know. Graph the function, plot those ordered pairs on the ordered plane, and then finally list an ordered pair not included in the table, but that is part of the relation, that is on the line. Okay, so four things for each situation here. Let's do the first one. It's the first one together. X of -2, y of 0. What ordered pair is that? What ordered pair does that represent? X of -2, y of 0. How do we write that as an ordered pair? Tony? -2, 0. Yeah, exactly that. Okay. Remember that in an ordered pair.
We have to do the unplugging thing.
Is that what the fix is? The unplug replug. In any ordered pair, the x value comes first. Hold on, it's got to figure it out. Okay, try this again. In any ordered pair, the x value always comes first. That's why there's an ordered pair. There's an order to it. So if you think about this as, what's going on? That's not green. Okay. In XY form, whatever x is, that's your x value.
Use black, see if it's green.
Okay. And then whatever y is, that's going to be your y value. So x of -2, y of 0 is your ordered pair -2, 0. The next one, 0, 2. The next one, 2, 4. And the last ordered pair in this table, 3, 5. Okay.
You just try to laugh and see if it's really.
I'm not seeing my my smartboard stuff up in the corner, so I think I'm gonna have to restart it. I think this is just. But we'll see what happens. Okay. When we go to the rule of the table, so letter B here. Okay. What we're looking for is how do we get from x to y, right? The rule of the table is the equation. Hold on, I'm being. This is interruptions. Remember. Yellow. Confirm. What are you doing for lunch?
Me?
No, Carter.
Oh, hot lunch.
Hot lunch. I do. Yes. Lunch order. Yes. Cold. Did we just totally botch the attendance today? Oh, okay. Right, she's in religion. Okay. Bye-bye. Whew. All right. Let's try and write the ship
Did you
here.
unmute your mic?
Okay, a rule for the table. Basically, as you look from your x value to your y's, how are you noticing what's the pattern here? The rule for a table is essentially a pattern of how we get from our x value to the y value. Okay?
Well, technically, there's two ways to write it. One of them is y equals x plus 2.
Okay? Y equals x plus 2. Right? Whatever. Oh. Well, that.
I'm so smart.
I didn't do anything.
It doesn't have the black marker in his hand.
Good job, dude. You need to chill out there.
I didn't do anything. I literally just answered the
Good
phone.
job, Mr.
I didn't do anything. I don't know what's going on. Anyway, yes, Kate is correct, right? To get to y, whatever x is, you're adding 2 to it. -2 plus 2 equals 0. 0 plus 2 equals 2. 2 plus 2 is 4. 3 plus 2 is 5. The rule of the table is that pattern. How do you get from your x value to your y? Now, Kate said there's a second way to write it.
So remember that it's x plus 2 equals y.
Sure. If you want to write it x plus 2 equals y, that works as well. They mean the same thing. They're interchangeable there. Jack, question?
Can I go get a pencil?
Sure. Letter C now, graph the function. This is where we take these four ordered pairs that we have here, and we put them on the coordinate plane. Now, all of these coordinate planes have the x-axis and the y-axis labeled for you. Not all of them in the future will. So you do need to know which is x, which is y. That's going to kind of help you know where to plot one. So the ordered pair -2, 0, x of -2, y of 0. -2 on the x-axis. And we're not going up or down the y-axis at all, so it's right on that horizontal line. 0, 2, 0 on x, 2 on y. It's going to be there. 2, 4, 2 on the x-axis, 4 on the y-axis. It's going to be there. And 3, 5. 3 on the x-axis, 5 on the y-axis. It's going to be there. Okay. Now, what do you notice about my 4 points here? Annie,
Form a line.
they form a line. When you plot your points, if they do not form a line, you've got at least one of them in the wrong spot. Okay? I've set these up to be lines for a purpose so that you can kind of check yourself, make sure you're plotting these points correctly. Right? If you plotted, if you're trying to plot 3, 5, and you put it here at 5, 3, because you got the x and the y backwards, right? That's not in line with the other ones. So you would know it's in the wrong spot. A built-in safety net for you to check and make sure you are doing this correctly. Now it won't let me erase it. Unless it erases half of everything else. Okay, so we've graphed it. It's on there. Letter D says, list an ordered pair not included in the table, but that's on the line. So to make our line, we're going to connect these as straight as you can. Okay? And it is a line, so notice the arrows on each end here continues on forever in both directions. What's an ordered pair that's not in the table but is part of the line here? Lexi.
-4, -3.
-4, -3. That's going to be down here. I think maybe that -4, -2.
Yeah.
Okay. -4, -2 would work. What's another one? Jack.
-1, 1.
-1, 1 works. Camille?
-5, -3.
-5, -3, that works. Okay? And you can check these answers not only by looking that they're on the line, but also, does our rule apply? Starting with whatever x value that we have here, if you add 2 to that, do you get the y value? -4 plus 2, -2. -1 plus 2, +1. -5 plus 2, -3. Right? I kind of get a little bit crooked here at the end, and it looks like I've got a point here at -6, -5. If I write that down, I say, well, does it follow my rule? What's -6 plus 2?
What?
Right? Y should equal x plus 2. -6 plus 2 isn't -5. So then I look back and say, oh, I kind of got a little bit sloppy here at the end. My line should continue down like this. Right? That point isn't actually on it. So you can kind of double check your answers by verifying, does my ordered pair follow the rule that I came up with for the table? Okay? Jack.
So for D, do you only need to do one or?
You only have to do one.
Oh,
Yes.
okay.
Yep. We just took several of them. Questions on any of this process? Okay. Are any of these letters unfamiliar to you? Like, have you done rules of tables before? Have you plotted points before? Have you connected them in a line before? Is it all basically just review for you, John?
Yes.
Good. Okay. Good opportunity to plug some holes maybe that went dug along the way. Okay, next one. -3, -2. Again, we're writing these ordered pairs. The x value always comes first. We need parentheses around them, separated with a comma. That's the notation for an ordered pair. -1, 0. 0, 1, and 2, 3. Negative 3, negative 2, negative 1, 0, 0, 1, and 2, 3. What's our rule for the table? Letter B. What's the rule? Haley. Y equals x plus 1, or if you want to write that x plus 1 equals y, that is totally fine. But basically, what's the pattern here to get from x to y? For every x value that we have, we're adding 1, and that brings us to y. Okay? Plotting these, negative 3, negative 2, negative 3 on x, negative 2 on y. Negative 1, 0 is going to be on the x-axis right there. 0, 1, smack dab on the y-axis. And 2, 3 right there. To make a line, that's good. We've done this correctly. We can connect these points as accurately and as straight. Whoop. I don't know if this is going to work out well. As you can. Okay? And then give me an order pair that is part of the relation, but not in the table. Sophie.
4, 5.
4, 5. 4, 5. Let's make that point bigger so it fits on the line. Good. And how do we know that 4, 5 works? How can you defend that choice?
Because it follows like the rule.
Yeah. If our rule is x plus 1, 4 plus 1 equals 5. Camille.
Negative 4, negative 3.
Negative 4, negative 3. That works. Right? Negative 4 plus 1 is negative 3. Griffin?
Negative 2, negative 1.
Negative 2, negative 1. That works. Negative 2 plus 1 is negative 1. Okay, Abby?
2, 1.
2, 1.
Or 1, 2.
Ah, there you go, right? 2, 1. If we plot that, A, we can see it's not part of the line pretty clearly. And also, if you write that in order pair 2, 1, 2 plus 1 would give us 3, right? Which we have is on the line here. So 1, 2 would be correct. 1, 2 is on the line. Very good. Haley. 3, 4 on the line, right? A lot of different options here. Lots of different options. Questions on these? Kate.
Where do you get the 1 in the y equals x?
We look at how do we get from this x value to that y value. And then is that consistent throughout the table? Negative 3 plus 1 gives us negative 2. Negative 1 plus 1 is 0. 0 plus 1 is 1. 2 plus 1 equals 3.
What would you do if it wasn't consistent?
If it wasn't consistent, then that's not the rule. Okay? Like if, we'll get some of those. Questions so far? Okay, I think you have like 6 others to do. Let's do another one on this page. Kate, is there one that you got to that you got stuck on, or?
No, I was just asking.
Okay, Tony?
The only part I'm confused at is the rule for the table.
The rule can be a little bit tough. Okay, so have you tried one of these two yet? No. So let's. Which one would you like to do?
That one.
Left or the right one?
The left.
Left. Okay. So looking at this one, first we're going to write our ordered pairs. Okay. So we've got x value of negative 3, y value of negative 6, x value of 0, y value of negative 3, x value of 2, y value of negative 1, and x value of 6, y value of positive 3. And now, to find that rule, you're essentially looking for that pattern. How do I get from negative 3 to negative 6? And then is that pattern consistent throughout the table? For example, you might think, oh, okay, negative 3 times 2 equals negative 6. Maybe my rule is x times 2. But then you look at the next one, 0 times 2 isn't negative 3. So even though it works for the first one, since it's not consistent, it can't be a rule for the table. So what's another way to get from negative 3 to negative 6?
Minus 3.
Subtracting 3, right? Negative 3 minus 3 is negative 6. 0 minus 3 is negative 3. 2 minus 3 is -1, and 6 minus 3 is 3. So the rule for the table, in a sense, it kind of goes back to just number sense. You know, what are some different ways I can get from here to there? And then does that work for all of them? So the rule for this one, y equals x minus 3, or x minus 3 equals y. You can write it either way. Okay. Questions on it? Do I have to keep going on this one, or do you want to go to a different one? Any thoughts? Any, you don't care? Let's look at the backside here. Okay, pick one from that backside. Same directions, same process. Okay? But write down all the ordered pairs. We'll take the strings too. There should be a spot where you write down the ordered pairs from the table. Okay? Actually, write down the ordered pairs. Practice writing parentheses, commas, x, y. Good. Do it here too. One on the back side, or the second page, you'd like to take a look at. One that's particularly worth our time. What do you think? That was cold. Camille. Third one. All right. So our ordered pairs that we're dealing with here, we've got -4, -2, 0, 0, 2, 1, 6, 3. This is the one on the bottom left on the second page. And now we look for the rule. How do we get from x to y? Yeah?
X divided by 2.
X divided by 2. How did you know that this was going to involve some multiplication or division? Did something kind of tip you off for that, or just kind of play around with it and that's what you came up with?
I just played around.
Okay. Which ordered pair here is a clue that it's not going to involve any addition or subtraction? Abby? 0, 0, right? Because if we start at 0 and end at 0, well, that means we're not adding or subtracting anything from it. So it's going to involve some multiplication or division here. So then we look at the rest of them and we might say, oh, hey, you know, especially with the positive ones here, you know, 2 is double 1, 6 is double 3. So to get to y, we're taking x divided by 2, and that equals y. Right? Some of you might have looked at this and thought, oh, hey, 1 is half of 2, 3 is half of 6, whatever x is, I'm taking half of that number, and that will bring me to y. And it turns out both of these mean the same thing. Dividing by 2 and multiplying by 1/2 is the same operation. I shouldn't say that. Different operations, same result. Okay? So you can write it either way. Either way. Okay? Good. Let's look at the last one. Let's look at the rule for the last one here. How do you get from -2 to -3, from 0 to 1, from 1 to 3, and then 2 to 5? I'll give you hints. This one involves 2 operations. So first you do something, and then you do something else. Okay? And you know it's going to involve 2 operations because of, you know, here we're increasing by 1, here we're increasing by 2, here we're increasing by 3. The difference between these numbers isn't the same. So there's something else going on here. It's not just addition, subtraction. Something else is going on here. Anybody see it?
Square root.
No roots. I would not be mean enough to throw it at you. Shay. Okay, we are multiplying. That's part of it. Jack? No?
Wait.
Abby?
Well, I'm seeing like a 1 times 3 plus 3, and then 3 plus 2 equals 5.
Okay, so there's that relationship there. Unfortunately, it's not with the same operation. So that's not going to really help us to write the rule. But you're seeing connections, which is good. The fact that this 0, 1, this could be helpful to us because the difference between 0 and 1 is 1, right? So our final step here, when we write the rule, we know that the last piece of it is adding 1. Because something gets us to 0, and then we're adding 1 to get to 1.
Multiply by 1.
Okay?
Y equals 2x plus 1.
There it is. Very, very good. Y equals 2 times x plus 1. 2 times x plus 1. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. 2 times 0 is 0. Plus 1 is 1. 2 times 1 is 2. Plus 1 is 3. 2 times 2 is 4. Plus 1 is 5. Okay? When you're looking for the rule, sometimes looking at the negative one, it kind of messes with your brain a little bit just because it's backwards, you know? So focus on those positive ordered pairs and look for that pattern there. It's usually easier to see. But there you have it. Okay? The rule is y equals 2x plus 1. Yeah?
The one above that one, I'm super confused on.
For the rule or for something else?
The rule.
Okay? Top right corner. Negative 3, 6. Negative 1, 2. 0, 0. What does this 0, 0 tell us?
0 equals 0. You're not adding multiplication.
It means that there's no
Adding
addition or subtraction. Okay? So it's going to be multiplication or division. And how do we get from negative 3 to 6, negative 1 to 2, 2 to negative 4? Something to notice here is that the sign changes in all of these, negative to positive, negative to positive, positive to negative. That might be a hint. Haley? Very good. Y equals x times negative 2, or you can also write that y equals negative 2x. Whatever x is, we're multiplying by negative 2. That's going to double it. That's why we get from 3 to 6, 1 to 2, 2 to 4. It's also going to change the sign because it's negative. An x value that starts negative multiplied by a negative brings you to positive 6, and so on and so forth. Okay? Yeah. Any questions on the plotting and the connecting and the writing of the ordered pairs, not on the line, but part of the function? That part's good. Blake?
When are we going to use this?
Uses in life. So if anytime you've ever looked at a graph, right? If you follow the stock market, you know, if you follow just any sort of data,
See his pattern.
looking for patterns, you know, I mean, that's important, right? Try and predict what's going to happen next. Basically, all of math, all of algebra, the cop-out answer to that question every single time is we use what we know to find out what we don't know, right? We're using what we know about the ordered pairs in the table to find an ordered pair that's not listed, but is part of the relation, okay? So we can predict what's going to happen. We can analyze, is something working, is something not. That's kind of where we're headed with this. Okay. You also need to know for the test. That's probably the cop-out answer for the test. But yeah, you know.
Do we need to do the arrows?
The arrows. Oh, on your lines?
Yeah.
Yes, you do need to do the arrows.
On the segment.
Sorry for all the extra words, but yes, you need to put the arrows.
We only have to do like 1 or 2.
Okay. All right. This homework is going to be due on Thursday. Since tomorrow I will not be here, and you'll have your definitions quiz. So an extra day to do it. Questions, comments, concerns, complaints, comments, congratulations, criticisms. Johnny,
Congratulations!
thank you very much. Anything else?
No.
All right. Have a good day, everybody. That's my math.
Don't forget to